Alright, let's take a look at target 64, which is evaluating functions and composition of functions. So we're going to be plugging functions into other things. Now this problem starts out with doing f of 3, which is something we've been doing for a while. So we just take the 3 and we plug it into the f function where x is located. So we're going to do 2 times 3 squared minus 4. 3 squared is 9. 9 times 2 is 18. So we're going to do 18 minus 4 or 14. So f of 3 generates an answer of 14. So f of 3 equals 14. 3 is the input, 14 is the output. Now, we're going to use that same idea as we do this question here where it says find g of f of 3. On this kind of a question, we have f of 3 that we need to figure out what that's worth. We're going to start in there and we're going to work our way out. So we already figured out f of 3, that's worth 14. So now I know that that's 14, and then I'm going to do g of 14 because f of 3, that's how much it's worth. So in the g function, I'm going to take 14, I'm going to plug it in for x. So then that would be 5 times 14 plus 3. 14 times 5 is 70, 70 plus 3 is 73, and that's my answer. Okay, the next part is f of g of 3. Now in this particular problem, I'm going to be doing it where I'm taking f of g of 3 instead of g of f of 3, so this is the opposite plug-in. So g of 3, I take 3 into the other equation, which is the g equation, and I get 15 plus 3 is 18. And then as soon as I have 18 there, then I'm going to start in here and work my way out. Now I'm going to do f of 18 because that was my answer. So take 18 and plug it into the f function, squared minus 4. 18 squared times 2 is 648, minus 4 gives me 644. And so f of g of 3 equals that. The key to this strategy is you're plugging in the inside function first and then the outside. Now a follow-up to this is whether or not proving that these two functions are inverses. So as you continue to do this, if these functions would have been undoing or inverse functions, then f of g of 3 would have equaled 3. Had it equaled 3, that would have meant that g would have turned it into some number, and then that number would have got plugged into f, and it would have given us 3 back. Then we would say that those are actually inverse functions of each other. When you plug a function into another, and you get that same number back, so when I plug this number into this function, get the answer. So if 3 would have turned into something else, let's say it would have turned into 18, then that 18 would have turned back into 3, then we would say that they're undoing or inverse functions of each other. Now, those kind of questions are something you're going to have to be able to deal with. You're also going to be able to have to deal with plugging in a whole equation. So in this type, where it's g of f of x, you take the whole f of x function, the whole function, and plug it in for x on the other problem. So then that would look like this. 2x plus 5 quantity squared minus 10. And then you're going to have to multiply that out with 2x plus 5 times 2x plus 5, and then of course minus 10. Work all that out and see what it equals. Now, in inverse functions, if you do f of g of x and it turns out where this whole thing simplifies down to plain old x, then we would say they're inverses. In this case, those do not simplify down to a plain old x, so they are not inverses of each other. So here is one way to state that and kind of clear that up. What you would say is if you plug in a function into another function and you get x coming out, then we say that they are inverses. And so then f inverse of f of x equals x. You work from the inside out when you do these problems, and it's called composite functions or function composition.